name is Robert Pearson, and I'm a student in the Chemical Engineering Stage Mass Transfer course, and I'm doing problem 2 called the absorber stricture extraction for exam 2. So essentially what we're looking at is what this diagram illustrates is by means of a plate column, acetone is absorbed from its mixture with air from a non-volatile absorption oil. A plate column is essentially a big piece of equipment that's used in a lot of chemical engineering industry techniques, and it's very useful for something exactly like this. So the entering gas stream contains 30% mole acetone and 70% mole air, and that's the entering gas stream. And of the acetone and air stream, 97% is to be absorbed, so 97% acetone is absorbed, and 10% mole of the acetone comes out in the exit stream down there. And the equilibrium relationship for this system is given small y equals 1.9x. So what we're first asked to find is the operating line. So I mapped out here that x equals moles of solute over moles solute absorbent, y is equal to moles solute over moles solute gas, and essentially I calculated all these using the relationships of just material energy balances in and out, and just essentially illustrating it through this diagram. The diagram is a really good way to see everything that's going on in the problem. So what we're trying to do with the operating line is trying to find 2 points here, and what those 2 points will help us do is essentially graph our equilibrium line and our operating line at the same time to further solve the problem. So I found that y1 is equal to this relationship, or this equation right here. So the 0.03 is from the 3% of acetone in the exit stream. The 0.3 is from the 30% of the acetone in the entering gas stream. And the 0.7 is from the 70 mole percent air in the entering gas stream as well. Now solving all that, we found the 2 points that we can now use for our operating line. So our next step was to find the equilibrium line. So we're given that small y is equal to 1.9x, and through these correlations we get 1.9x over 1 minus 1.9x to be our final equation there. So essentially what I did for the graph was I actually plotted in Excel, but for instructional purposes I have it up on the board for you guys to see. So we have our equilibrium line in black here, and then our operating line, more straight line, over here. Essentially what you do is using your points, you create almost a stair step going up. And I found it to be between 4 stages and 5 stages using the graphical way to solve it. So now we were asked to find the number of ideal stages required to achieve the separation using the Kremser equation. So A is the absorption factor. That's equal to L over KV. K is equal to 1.9 from the equilibrium relationship. And now we use the slope of the operating line, L over V, plugging in these points that we found through here. I got the slope to be 3. So now you can use 3 and 1.9 equation to find your absorption factor, which is equal to 1.8. Now, phi A is the fraction not absorbed, and that's equal to 0.03 because 0.03 of acetone comes out here where 97% is absorbed. So next we're looking for phi A, and that's equal to A minus 1 over A to the n plus 1 minus 1. And then plugging in those numbers, solving for n, we find n to equal 5 stages to achieve the desired separation. So using the Kremser equations, we found n to equal 5, whereas graphically we found n to equal 4 stages. So that's the difference between using it for my calculations from the graph and then using the Kremser equation. So now I'm going to use the Kremser chart to find the number of stages required to achieve the desired separation. So what you do is you go to your value, your absorption factor, which is 1.58, and then you go down to your 0.03 value down here. Essentially what you do is you draw a line, and wherever the line connects, and that gives you the desired number of stages that you're looking for. So that's how you use the Kremser chart. And like I said, I had 5 stages with the Crimsor equation, then graphically I had 4 stages, and that's the chart that I just showed how to utilize. So in conclusion, those were differences, 5 stages and 4 stages. This is how you do the problem. I'd like to give thanks to Professor Smith, Prashant, and my Handy Day textbook for helping me through the way. Thank you.